Yeah, hello everyone. My name is Kelvin. Today I want to do a very interesting workshop about maths in what we call the interactive problem solving in mathematics. Actually, this methodology will be one of the best, and I know if you are going to implement this in your classroom as a teacher, as an educationist, as a policymaker in education, you're likely to get some good insights about the current modern pedagogical strategies that we have. So I'm Kelvin, I have a master's degree in physics education. I specialize in STEM educational consultancy and all that. So today we are going to look at interactive problem solving strategy. Our learning outcomes shall be for I expect by the end of this workshop or this training, I will be able to identify some of the key components of the interactive problem solving in mathematics. And of course, this you can also apply it in across in other subjects that you're teaching as a teacher. Uh, we hope that at the end you shall be able to design and maybe develop a CBC aligned lesson plan or any curriculum that you're teaching, be able to come up with a lesson plan that incorporates the interactive problem solving. Currently, we don't talk of CBC, it has been changed to curriculum based education, that is CBE for the Kenyan context. But whichever context that you're teaching, we shall learn how to create a lesson plan and incorporate this methodology. Then there is we shall see how can we implement the interactive problem solving activities to be able to enhance the high order thinking skills, that is critical thinking, the collaboration and problem solving skills. And then of course at the end there is a need that you'll be able to recognize the importance of maybe the interactive problem solving in enhancing learners' ability to apply maths in real world. So what is interactive problem solving? Um, Interactive problem solving simply is like a hands-on, student-centered approach. Uh, when we talk about interactive, like the learners actively explore, they discuss, they solve, real life problems. And as they solve, discuss, actively explore, they are doing it together. And this whole thing builds what we call a deep understanding through what we call collaboration, critical thinking, and creativity. So our main target in this interactive problem solving strategy is students' collaboration. How can we enhance these students' critical thinking and creativity? And all these shall be able to bring them when the learners are allowed to, explore actively, solve some real life problems in their environment, or maybe in the larger community, or maybe in a country, or maybe a problem facing and all that. So in the interactive problem solving, we talk of three main things. That is active participation, the collaboration, and then the real world connection. We want these learners, we expose them to activities that these activities will make them to creatively think. And when they creatively think or critically think, they'll be able to come up with a solution to a real world maybe problem and all that. So in the active participation of the learners, when you bring them together, it brings what we call the development of high order thinking skills, the analysis, the synthesis, the evaluation, all that comes out through the active participation of the learners. And then in the collaboration, here we are enhancing the student engagement by, we are moving away from the traditional lecture methods where the teacher will come to the class and stand in front and lecture and give student content and leave. But for this case, we want to engage the learners. We bring them together. Let them be in groups. Let them discuss in pairs. Let them work on a project. let them come up with ideas on how they can be able to solve a problem based on what they are learning. And then interactive problem solving will also prepare students for real world problem solving. And in this case, will be done by mostly the creative and the collaborative efforts. And therefore, I designed this diagrammatic view. At the center, we have what we call the IPS, that is interactive problem solving. And then it is connected to these three: collaboration, active participation, and real world connection. And in all your classes, make sure the content that you are teaching allows learners to explore and even, try to relate it or try to connect it to the real world connection, the aspect that mathematics actually should be doing. I used an example of the ninth grade where we have a strand or a topic called measurements. And our teacher wants to teach about mass, volume, density, and weight. From the traditional methods, you just go to the blackboard and or the whiteboard or whatever you're using, and then you tell the learners density equals to mass over volume, and then you give them questions and allow them to work on that. Then you give exercises. But in the interactive problem solving, you have to bring it in a way that learners can connect the density you're teaching, the volume, the weight, the mass, to a real world situation. So we are saying instead of you doing the traditional method of teaching in mathematics, you can decide to present them with a scenario, present. That is the main term. Present them with a real world scenario. Maybe you can ask them to calculate, the density. So when they are calculating the density by measuring, so it means they are doing. So they might be doing in groups, they might be doing in pairs, and when they measure the mass, they are learning how this mass happens, or they can connect the measurement to real world case. Let's say, for example, they are measuring the mass of maybe a mass, maybe of weight. Maybe they're measuring the mass of a bag of maybe, let's say, for example, a small bag of sand and all that. So when they are measuring, they can relate it to the measurements that are done in the shops using a weighing balance. So you are connecting the students to real world scenarios. Then we have the case of, you can have them explore the density of materials and how it affects buoyancy, the floating and sinking. You can give them different, let's say, materials and allow them to explore. Give them water, which is readily available in most cases, and let them try to figure out why is it floating, and then connect that idea to a real world. Real world means that now, from what they have been measuring and trying to explore when measuring mass and volume of objects, whether they are irregular or regular and all that, they'll be able to connect this to, let's say, for example, engineering applications. The idea of making ships, why ships float on the surface of water, and very many other things. So you can encourage learners to work in groups to collect data, different values of mass, different values of volume, and let them discuss their findings. How do they see the relationship between mass and volume? And automatically they will have learned density. But when they have been exploring, they have now gone to this part where we talk of the learners have now been able to, let's say, for example, they have been able to come up with a measurement of density, they have come up with a measurement of volume, they have connected it to real life. So that is what we call now the collaboration, active participation, and real connection. Uh, Another example is like you can use real world problems like budgeting for a school event. So if we have a school event, maybe we have sports day. You can ask them to come up with budget, and when they are budgeting, they'll come, in teams. They'll be able to calculate maybe the cost. This one needs this needs this, and from there they'll be learning basic algebra. They'll say maybe to feed the whole school, we will need a minimum of 50 bags of rice. So that's linear inequality, because a minimum of 50 bags. It means it should be, 50 bags and more. So we'll talk of greater or equal to 50. So you can be talking of at least, at most. They'll be doing approximations, and that one fits very well in algebra. A combination of the boys and girls and all that. They can form linear equations and see which specific amount will a student maybe intake in that. So this presenting solutions and explaining their reasons to the class gives them an opportunity to be able to collaborate, to be able to actively participate in learning, to be able to connect the content that real world. We have four main strategies that I came up with to help in the interactive problem solving. One is what we call the problem solving circles, the math debates, the math stations, and the peer teaching. So if we are going to tackle each one of it, we have the problem solving circles. Just from the word circles, you know, we are keeping the learners to be in a loop. So they come from maybe point A, point B, and that we're keeping like a loop. We're allowing the learners to be able to explore and work out the values. So in the problem solving circles, we put learners into small groups, and we give them, let's say for example, parts of a problem for them to solve. We know very well we have this thing of what we call the composite shapes, like a trapezium, like a trapezium. It looks like that. So if we divide a trapezium, let's say for example, into different parts, this is what we are likely to have. So we have part A, we have part B, we have part C. So I can decide to, instead of allowing learners to work the area of a whole trapezium, I can decide to allow, divide the learners into three groups. Group one works on A, to finding the area of A, which is a triangle. Group B finds the area of B, which is a rectangle, or it might be a square, whatsoever. Then group C or group 3 works on area of the triangle C. Now, this is like you have created a circle. So in the end, group A will share and present in the class how they found the area of A. B will find how they found the area of B and C, and of course they'll present to the class. When they present to the class, that group which was in the second group which did area of a rectangle will be asking questions. How did you find area of a triangle in group A and in group C? So in the end, it will encourage the different learners to come up with different methods to solve. So we are talking of, if it is a composite shape, divide it and give to different groups, and they work on it. When they work on it, let them come and present in front of the class and work out, and let the other members ask questions. We did not work part A, but how did you come up with this? So when they are presenting, they ask questions. So in the end, you've created what we call a problem where learners can be able to explore. Math debate, this one is also a very important part in teaching of math. In most cases, the math classes are very silent. Students don't talk and all that. They don't ask maybe sometimes questions. Maybe it's because of the environment they are in, or the fear, or they don't get the opportunity to express themselves. So you can present a problem which has multiple solutions, and then like for example, in algebra, we have this aspect where they are supposed to solve simultaneous equations. Simultaneous equations can be solved in very many methods: elimination method, substitution method, graphical method, matrix method. So you give them a problem that has multiple solutions, then put them in groups and allow them to explore. So they'll be able to come up, this one will be saying we should use this method, this one we should use this method is the best, this one, and then in the end, they shall come up and critique each other's approach. So group A will present and say, we are working with matrix method and all that, and they defend. Group B will come and say, matrix method is good and best, but I think substitution method was the easiest to use to save on time, and they'll be defending their solution. And in the end, they'll come up with what we call a math debate. Now, this math debate, its main aim is just these two things. Like it generates what we call critical thinking and problem solving in the students. They'll be able to think. You present a problem to them and they start asking questions like algebra and linear inequalities. Which is the best method of finding the wanted region in linear inequality graphs? So they'll be trying to think, we've only been taught this, we only know this. Is there any other way? So they'll be debating. I think using the signs will give me the best and the y-axis. Others will say, no, we pick any point and try to get if it fits, and the point which is outside the region. So, and all that. So when they are arguing, they come up with what you call critical thinking and problem solving. Remember, we are targeting the learners, no, not just necessarily for the low order thinking skills where they need to remember, memorize things, and reproduce, comprehend. We are now looking at the high order thinking skills. And the high order thinking skills, we must bring out a way in which these learners, we can be able to spark them through active participation and collaboration so that they might think critically and come up with what we call the problem solving skills, knowing that we can be able to come up. And in the math debate is very interesting because you'll realize that some learners will come up with different methods which are not even in the textbooks, which are not even in the curriculum, but they work. So in such cases, it means it has created creativity and innovation. So students will research, that is the main thing also, and debate which method is more efficient. So after, and why? So after they have said like this method is good, this method is good, this one is better, this one is, so they debate, then at the end they'll have to agree. Like, we think even though we used this method, but I think the method for the third group worked better because it seems to be easier to comprehend and you easily arrive to the answer without maybe spending a lot of time. So that is the main of math debate. Then we have what we call the math stations. For the math stations, it's very easy. You present, let's say for example, you create 4 stations or 5 stations in a class. In that 5 stations, you put 5 different questions for learners to work. So the learners will be going in station 1, they work out a question. After they finish, they go to station 2. Then they go to station 3. Then they go to station 4. So they will be rotating. So maybe we have 5 groups. While the first group is on station 1, the second group is in station 2, and so on and so on. And then once they finish the questions, they move to the other station. So that at the end, all the learners will have solved all the questions in the 5 stations. So in the math stations, this one, we have a lot of movements because the learners will not be sticking to one place, or you are not giving them questions while they are static in one group. They work in this station, they move to the next station. They work in that station, they move to the next. Now, that rotation should be timed. So you can decide based on how you've given the assessment or the questions. You give them maybe 10 minutes or 15 minutes or even 7 minutes and tell them, I'm giving you 7 minutes in every station. So at the end of 7 minutes, you have to stop the time. And all the groups, whether they have completed or not, they'll have to change. The advantage of this method is that you'll realize learners will have to know how to manage time when they are working on tasks. And that group which will keep time and do most of the questions or complete the questions emerges the winner. So they realize that when they walk into the group, they mean business. They don't have time to make stories. They mean business. And if time elapses, you have to stop and move to the next group. So they'll always be in a hurry to think very fast and make sure they come up with solution and allow them to explore other. And after the math stations are through, give them an opportunity. I know we have a problem with time. Maybe your time is 40 minutes and all that. You can prepare 3 math stations. Let them do it in 30 minutes. Then in the next lesson, you can come and allow each member of the group, after marking the work that they have done and you release the results, allow them now to discuss their work. Then we have the aspect of peer teaching. Learners learn better from their partners. That has always been the truth because of the gap or the distance between the teacher and the learner. So a learner understands better when a fellow learner explains a concept to him, because maybe he will explain in a language he understands or is more better. Maybe that uh, distance between the teacher and the learner, the relationship is far much away. Some learners just fear teachers because of the gap, and they feel more comfortable when they get the information from their fellow student. So the peer teaching becomes now a very key, a strategy in interactive problem solving. That after solving a problem, students take turn teaching the solution to their peers. And that's why we talk now, the teacher is supposed to facilitate the learning process. Give them work. They have been in the math stations. They have debated, over an issue. They have, come up with different methods. They have discussed. Give them an opportunity. In those groups, you will find out some learners coming out to explain the concept better to the other peers in a language they can understand. And this one, your work will just be very easy as a teacher. Your work will just be to observe and clarify on the concepts that have been missed. And peer teaching, I can say it reinforces the understanding. What they have discussed in the math station, what they were doing in the math debates. Now, the learners now come and discuss it. So it will reinforce their understanding. And it will also help the other learners to learn in a different way, knowing that it's not the teacher who is the only source of knowledge. Even us, we can contribute to that. And then we have, this is some of the activity that you can do to be able to explore interactive problem solving. Maybe you can form 5 to 7 groups of learners, or whichever you are comfortable with. If it's pairs, it's okay. If it is 3 students, it's okay. If it is 10 students, it's okay. But at least we advocate for smaller groups, like 5, 3, 5, 7 is okay, or 2 is okay, but too much large groups also will be challenging to work with. So you can pair the learners into 3 groups and assign them math stations. So maybe station 1 they are working on simultaneous equation. Station 2 is working on linear inequality. It has questions on linear inequality. Station 3 has questions on geometry. So the learners will be rotating. Work in station 1 on simultaneous equation, work on linear equations, inequalities in station 2, and in station 3, you're supposed to perform a task on geometry. So then allow the learners rotate, explore, let it be timed, maybe in 10 minutes, then selected groups to present. Or if you have more time, all the groups can present and that is the best. Now, we go to what we call lesson planning. Failing to plan is planning to fail. That is Alan Lakin. He talks about that. If you don't plan, then you are just planning to fail. So when a teacher is planning, like for our Kenyan context, we have the curriculum-based education, competency-based education curriculum, CBE. I don't know about your country, but when lesson planning, always consider these two things. One, competencies, and two, values. This is the main target. We have what we call the 21st century skills, and our curriculum has narrowed down to 7 competencies that they want our curriculum to address. So it's not a matter of going and teaching. What are you targeting? Do you want to help the learners, grow the skill of or the competence of communication and collaboration? Do you want to target citizenship? Are you targeting imagination and creativity? Are you targeting digital literacy? Are you targeting self-efficacy? So those competencies, they're the ones you should be having in mind. When I'm setting up a math debate, what am I targeting? The math debate you might even put an ICT activity. And the students research, maybe they search the number of sides of, let's say, for example, a 12-sided figure to a 30-sided figure. So those things are not in our textbooks. If a learner asks, what is the name of a 25-sided figure? But the 7-sided figure. So you can give them an activity like that, and you are specifically targeting a competency of digital literacy. And digital literacy, it is not the teacher doing for them, it's the learner doing the work. Then you should also look for the values. Which values do you want to inculcate? If, let's say, for example, I want to maybe inculcate a value like, let's say, for example, a responsibility, putting learners in groups, and they are working in those groups, and you appoint some leaders, then all the learners appoint leaders for themselves. Then you are also targeting that value of responsibility. So peace, unity when they are working in groups, patriotism for their country when they are working for a project, let's say, for example, that is helping reduce, let's say, for example, things like environmental degradation through erosion, soil erosion, and all that, food security. You are teaching them about the value. Now, in the lesson planning, we mainly look for the main things. And the main things is like the learning outcomes. Your learning outcomes should cover all the 3 domains of learning. The cognitive domain, the psychomotive domain, and the affective domain. So I usually say the cognitive domain and then the psychomotive domain, what the student can do or is able to do. Then the affective domain. Now, affective domain is tied to feelings and appreciation, recognition for what he has done. Like if you're working on linear inequalities, how does linear inequality help you in real life? What is it that you can appreciate that linear inequality has helped you? When we are talking about age, you are more, your father is more older than you, and you're working those sums and all those things. So how do you appreciate what you have learned? So those 3 things are very key. Make sure you get the cognitive, the psychomotive, and and the affective domain. And in our CBE lesson plan, we talk of knowledge, skill, attitude. So this is a simple lesson plan template. It has administration details, which I don't want to go into that. But the strand, to some curriculum, they have what we call topics. You have to write it there, substrand, the subtopic, and then the specific learning outcomes. So you should say, by the end of the lesson, what do you expect? The learners should be able to, let's say, for example, they should be able to do what? So you target the knowledge, you target the skill, then you target the attitude. That is the main thing. Your learning outcomes should not be one. They should be at least three. And it's not tied to three. You can even have six. But the thing is, are they achievable? The learning outcomes, they must be smart, specific. They should be measurable. Can you measure them? They should be attainable or achievable. So if you have six learning outcomes, the question will also be, will you be able to achieve them in maybe a 40-minute lesson, in a 35-minute lesson? So it's something that is point to discussion based on what you want. But you can have four, you can have five, but as long as they can be achievable in that lesson. The key inquiry question, what key inquiry question is what your lesson wants to answer. At the end, what are you targeting? And the key inquiry question comes from those learning outcomes up there. Then you must state your learning resources. Organization of learning. Where will learning take place? Let's say, for example, math will take place in a mathematics class, and it shall be organized in groups. Students shall be in pairs. uh, you can break the monotony and say, maybe if there is a nice tree outside the school compound, or we have a hall, or we have a lab, maybe the math lesson will take place in a lab, in a computer lab, and it shall be organized in groups. All students will be working individually. So depending on what you want to be done, or it can be done outside the classroom environment, and always have the tendency of changing the environment from the in-class to the outside environment. Now, in the lesson planning, we know you have to come with introduction, captivate learners. Let them, whatever you are going to teach them. You're going to teach about density, mass, volume. Just come with a question like, for example, why do ships float? And and if you pick a piece of nail which is made of steel, you put in water, it will sink. Even if you put that steel to be in the shape of a boat, and you put it in water, it will sink. But why is it a ship which is made of very large and pieces of steel, but it does not sink? So capture the learner's interests, then now introduce the aspect of density, introduce the aspect of mass and volume, introduce the aspect of buoyancy, and real life experiences. Then lesson development should be in stages. In stage one, what are we going to do? In stage two, what are we going to do? In stage three, what are we going to do? So in stage one, we might be measuring volume. In stage two, we might be measuring mass. In stage three, we might be calculating or determining density. So, and in all those stages, let the competences and the values be mainstreamed in each step. So maybe in step one, they were discussing communication and collaboration. In step two, they were searching online, digital literacy. In stage three, they were presenting. So in that point, communication and collaboration comes in, self-efficacy can come out. So in all those stages, make sure you mainstream the competencies and the values that are being developed. Then a conclusion is always a summary of the lesson, or a review, and you can summarize in any way. You can summarize by asking questions. You can summarize by, just talking about what they have learned, and highlighting the main points, clarifying the main points, the main takeaway. You can even reinforce. Maybe communication and collaboration didn't work well. You can tell them, now in the next class, let us improve in our association and communication when we are presenting our ideas and all that. Then always give them an extended activity where the learners can go and do and explore about the content. So you have taught them about budgeting. Maybe they can go and explore budgeting in their at their home, and all that, or maybe in the school, or in their clubs, and very many other maybe school events that they in. So this is an assessment that I would like you to go and try. You can prepare a lesson plan from any topic of your choice, any strand of your choice. and try to see, can I include an interactive problem solving strategy? We've looked at the math debate. We've looked at the math stations. We've looked at the peer teaching and all that. So you can be able to come up with one of the best strategy that you want to use in your classroom as a teacher. You want to target maybe math debate in your lesson. Prepare a lesson plan for that. You want to try out the math station. When learners work in this station, move to the next station, then they rotate. You want to try out problem solving circles, where now you give up a main problem, break it into pieces, and distribute to the groups. Let them work on, each group works on its own piece, then comes to present on the blackboard and all that. Then you can decide to share your lesson plan, maybe in the comment section and all that. Now, action planning is a very important aspect of every training. Any information that you learn, you can come up with an action plan. An action plan is what you will go and do. How are you going to implement the knowledge that you have learned from a workshop? And that's the end. For more information and training, you can always reach out via WhatsApp. You can send a text message on that number or email and all that. In all, don't forget to subscribe. Thank you.